previously we discussed techniques we can use to boost our model's performance. These things included stopwords. Should we use stopwords in our analysis? Should we apply lemmatization? Should we count bigrams as well? So count words, but also include bigrams as features for our model. The question might come up with is, how much of a model's performance boost will we get by including these additional features? Perhaps it's a very small boost, perhaps it's a big boost, or perhaps we may see very little change. So let's answer that question and see how we can go about figuring out how much of a performance boost we get when using these techniques. For this example, let's explore just a very simple situation. We're going to explore, is it beneficial to include bigrams? And should we apply lemmatization? So remember, this is our workflow. Let's say we have our vectorizer and then our machine learning model or predictor, in this case naive Bayes. So what we really want to do is we want to experiment with modifying this unit, this step in our process. So if we use a pipeline, we encapsulate this in a pipeline, what we want to do is explore the hyperparameters for this model here. So we could go ahead and do this one by one. So include stopwords, not include stopwords, include lemmatization, not include lemmatization, and consider all the possible combinations. But it's a lot easier if we use the tools that scikit-learn already provides for us, things like Grid Search CV. So we're going to explore the combination. So explore using counting just the words or including bigrams, and it's also explore the topic of standard tokenization and lemmatization. Standard tokenization, I just mean where we take our text, our document, and we break it down into words, and there's no other processing involved. In lemmatization, we apply that tokenization process. We break that document into words or bigrams, depending on what we're considering, and then run those words through a lemmatizer. We get the lemma for that word. So basically, maybe a better way to say is lemmatize or don't lemmatize. So I can explore the benefits of, so there's 4 different combinations that we have, and I can do this very easy by doing something like grid search. So let's go ahead and do a train test split. We didn't do that earlier, but let's go ahead and do a train test split. So do that right there. From sklearn.model selection, import train test split, xtrain, xtest, ytrain, ytest is equal to train test split, pass x, y, let's just say a test size of 0.2, and let's set a random state of 0. I'll just make sure I have those, see what x is. I have not defined x. That's because I think I called them corpus and labels. Guess I didn't have those. Just run this. So it looks like I got to rerun everything. Give me a sec. Okay, so now I should have these things. Let's see, I have documents. Okay, this will be documents. Let's see if it's labeled as a variable. Okay. I run that. Okay, let's construct my pipeline. So my pipeline is a 2-step process. going to be the vectorizer. Let's just use TF-IDF vectorizer. And our classifier, in this case, multinomial Bayes. Param grid we're going to explore is vectorizer underscore underscore, and then we're going to say n-gram range 1 and 1 and 1 and 2. So 1 and 1 just means count words. This means count words in bigrams. And we're also going to explore tokenize. Let's just look at the keyword arguments. Let's see, look at the documentation for what that hyperparameter is called. So run this there. So tokenizer none. So overwrite the string tokenizing step while preserving the pre-processing and n-gram generation step. Okay, so that's what we want to modify. Using none just uses the standard tokenizer, but we can provide our own. And with the one we're going to provide is going to do the lemmatization. So we can say explore try none, but also try the lemmatized function that we define up above. That's called tokenizer. Let's make sure tokenizer. So that's our param grid. Then we can say grid search. I don't think I have defined grid search CV. Okay, I've imported there. Then grid search CV, pass the pipe. The param grid. Let's do 5 folds. Verbose equal to 1. Do grid search dot fit x train y train. Helps if you spell it correctly. All right, let's go to the fitting process, see what happens. Notice it has 4 candidates because it's all four possible combinations we have. We're saying explore using just counting words, count words in bigrams. Explore, go ahead and consider the case of the standard tokenizer or using a lemmatizer that we defined. So 4 possible combinations for these hyperparameters. So notice now by using grid search, I don't have to do this manually. Don't have to train the model, including with tokenizer, then train it without tokenizer, and model's performance is going to be all done nicely in grid search by using something like grid search. It's taking a while, that's fine. We also want to be able to explore is once we do grid search, can we retrieve the individual results of all the runs? Because at the moment we use grid search to figure out what's the best model, what are the best hyperparameters for the ones we explored, for the ones we investigated. But we haven't used grid search to investigate what were those results for those different runs, for those different combinations, for all of those candidates. So that's what I want to show you here in this exercise. While this is running, I'll go ahead and jump into the next question. So we say consider another source of data and see how well the model performs with this new corpus. So we use Wikipedia data, but we can also use other forms of data. So do you have any suggestions of other sources of data that we can use? You remember, any other sources of data we're going to use, we want to make sure, since we're doing supervised machine learning, we want to have a corpus but also be able to get labels for all the documents in our corpus. And ideally, we don't have to label our documents individually. In other words, look at all the documents and decide, oh, it's referring to Python the programming language or Python the animal. That's not ideal if we do that manually. It might happen. That might be a problem. But let's go ahead and see if we can use a different corpus, consider a different corpus for our analysis. Okay, this ran here. So I can say results. There's a keyword argument called CV results, so an attribute. of the grid search that's going to be a dictionary that's going to summarize the results. And let's go ahead and see what the best params were. And let's see what the best score was. So this will be print out the accuracy. Just print these things out, so I can take both of them. Run there. Okay. So it looks like when we did the analysis that the best model was one that just included words and just used the standard tokenizer, didn't do any lemmatization, and we had an accuracy about 88%. Let's go and explore these results here. Let's see what results is. So results, if I run this, is a dictionary. It's going to return a dictionary. It can be a bit messy, but we can see things that's going to give us. It's going to give us things like the mean fit time, the standard deviation of the fit time. So if we really wanted to, we can see how long did it train, how long did it take to train when we explored these different hyperparameters. So there's the mean fit time for one of them, it's about 4 seconds. And the other ones are a lot smaller. So what's happening here is perhaps this candidate probably used lemmatization. Using lemmatization is going to be slower because it has to process those words, has to refine the lemma. So perhaps these are referring to the candidates that had lemmatization. So the question is, well, how do we know what the candidate was for this run there? Well, let's go ahead and show you how we can do that. So notice we got a keyword called params. So this keyword params will help us out, will tell us what were the candidates, what were the parameters, what were the hyperparameters used for all the candidates. So candidate number 1, so this params, we use this, let's go ahead and do, since it's a dictionary, we can use that keyword called params, that key. Okay, so we get a list. We get a list of dictionaries, so it's a list. If we go and take out the length, we will notice that the length of this list is 4. So it's 4. So it's 4 candidates. And what it says here is that the 0 index of this list is a dictionary. That tells us the hyperparameters that were used for that candidate. So candidate 0 used just counted words and had just used a standard tokenizer. But the next one used a lemmatizer. Remember what we said? The second one was probably the one that used a lemmatizer because it took longer to train. Well, sure enough, we look at it and that's what this indicates. So I can use this params in the results dictionary. There is a dictionary called, a list called params. There's a value called params, a key called params. So the value is a list that tells you the candidates for each, tells you the hyperparameters for each of the candidates. So you can explore the individual results. But we haven't, let's go ahead and see where we can get the actual results. These are just the candidate orders. And that should be one called, there should be one called mean test score. So it's going to be the mean test score for those 5 folds for all the candidates. So if we run this here, notice we get an array of 4 values referring to each candidate. So candidate 0, which was the highest score, refers to use its hyperparameters that it used is going to be the 0 index of this list up above. So we can see here that if we include lemmatization, we actually had a drop in performance. And let's see how it performed if we included bigrams. In this situation, we included bigrams. So candidate 0, 1, and 2. Candidate 2, index 2, used bigrams and used a standard tokenizer. And including bigrams didn't really help out. So it's probably what's happening there is perhaps overfitting. Including bigrams or including new features, but in this case, we are overfitting with these new features. Notice this test score is significantly smaller than this one. So notice with the grid search, yes, it's going to be primarily used to figure out what are the good hyperparameters for my model, investigate these hyperparameters for these values. But notice what I want to show you here is we can use that same grid search object and analyze the individual results for all the candidates the model explored when the grid search explored. So we can actually answer questions like, does it make sense to use limitation? Does it make sense to use lemmatization? Does it make sense to include bigrams, to count bigrams as opposed to the usual words? In this example, that doesn't appear to be the case. Furthermore, other things that I can get from my from this results are the runtimes. So even if lemmatization had a boost in model's performance, we might want to consider, is it really worth that longer training time, that longer prediction time? Maybe it's worth it, maybe it's not. To answer that question, we have to consider other things for the model, but nonetheless, we can get these results very easily by using Grid Search CV.